Hey, it's Pete. Welcome back to the workshop. So I got the spindle motor mounted, but not without a problem or two, and I may have had to do a few sketchy things to make it work. I'm going to share that with you this week. So there were two parts to this project, the first being modifying the bushing for the step pulley. The original motor had a half-inch shaft, and the new motor has a 14 millimeter shaft, so we need to increase the bore size. Before doing that, I dunked a couple parts in the evapor rust, and that worked as well as it always does. I'm always impressed by that. I generally put the parts in at the end of the day. I come out the next morning, take them out, they all look practically good as new. So the first part of this project was to bore out the bushing, and in doing so, I realized I had a couple problems. The first of which was a problem I've had for some time, and that is the tailstock on my lathe does not want to bolt down securely to the bed. It won't lock in place. So when trying to drill something slightly hard like this bushing, all I succeeded in doing was cranking the crank and having the tailstock move backwards rather than actually drilling. So I decided it was time to fix this problem. Popped off the tailstock and started taking it apart. And I should have realized something right from the very beginning, because when I got to this set screw, the set screw was just barely screwed in. When I inserted the Allen wrench, the screw was basically up at the top of the threads.
There it goes. Because this has to go on here first. And then this has to go in.
So as I started putting it back together, I realized the set screw was going in much further, and I thought that I had fixed it. But that was not to be the case. I'm not really clear how this got like this. I don't recall having ever taken this tailstock apart in the entire time that I've owned this lathe. However, this problem has only been around for probably the last 3 or 4 years.
Hey, you see, that isn't right. Because that should not be able to come out like that. That's working properly.
So the set screw just wasn't in quite far enough. It was clamping against one of the high spots rather than actually going down in the groove that it was supposed to. So I just needed to take it apart one more time and fiddle that around a little bit, and then I finally got it working just like it was supposed to.
I think that might be it. Yeah, because there's a dead stop in there. That doesn't come out. Okay.
So all of this downtime was another opportunity to fix one more thing that had been annoying me for quite a while.
Oh yeah. I think we've got it.
The second thing I realized was that the bushing was probably just a little bit harder than I was expecting, so I decided to hit it with a torch to see if I could temper it a little bit and bring the hardness down to something that was more easily drilled. So I was able to get my drill through it, and that did a pretty decent job. And then my next step was to take a 14 millimeter reamer, and what I was hoping to do was to be able to ream a slightly oversized hole, because that's what usually happens when I don't want an oversized hole. I figured, well, this will be the time to do it. Unfortunately, this reamer did exactly 14 millimeters, and I needed that to be opened up just a little bit to be able to slide smoothly onto the motor shaft. So here's where things got sketchy. I discovered that I seem to have lost or misplaced all of my small boring bars, so I have no way to enlarge this hole. And I have ordered a new set, but with the current state of things, they're not going to be here for a few days yet, and I wanted to move on this project. I started thinking about it, and I realized I have a Dremel tool with a flex shaft. So I decided to give that a try. This flex shaft is a Dremel model 225T1 that's actually hard to find. Dremel changed the current version of this product. It now has a more ergonomic handpiece, but that would make what I'm going to attempt here impossible. There do seem to be a few aftermarket versions with a relatively straight handpiece, and I will leave a link down in the video description. So I've owned this Dremel tool for about 25 years, and over that time I've put it to use on many projects, so the bearings in this are far from new. I did have some concerns that I could possibly be destroying the entire bushing with this operation, but moving forward down the road, eventually I'm going to be switching out these step pulleys to a timing belt, so we'll need a new bushing at that point anyways. I really don't have that much to lose here. So I took it slowly with the Dremel set on the highest speed possible, and I'm not going to know what kind of run out I have until I get this thing mounted on the machine. So the next part of the process was to design the adapter plate to mount the motor to the top of the milling machine. And my idea there was to use the original plate as a reference, and what I was going to do was use my 3D printer to design and print a part. Thinking there that I could go through all the design work before committing it to metal. And it's a good thing I did, because it took me 4 tries to get it right. The first plate that I designed and printed up had a few issues, the first being that my 3D printer was not calibrated properly, so some of my dimensions weren't coming out right. In addition to that, I misjudged the bolt hole pattern for the levers so that they were not on the right diameter. So with my next attempt, things got much closer to the ideal. Everything was mounting up properly and looking good. I just had to focus then on getting the height proper for the motor to line up with the pulleys. I did a whole lot of drawing and sketching in CAD and both on paper, and somehow I still managed to mess it up, and I went way overboard. I had a huge offset which set the motor up way too high. I still don't know what I was thinking, but that one was clearly wrong. So the fourth time was the charm. I designed it and printed it, and it came out just like I needed it to. Everything lined up really well. My hope here is that I'll actually be able to use this part and run the machine with it in place, and hopefully use the machine to actually create the metal version of this part. These are sacrificial supports I'm removing from the countersink holes. These just help the 3D printer bridge over what would otherwise be an unsupported area when it's printing. I finished it up with a bit of cleanup. This stuff deburrs really nicely. This part was 3D printed in ABS plastic with a fairly high fill rate, and I prefer the finishing options that ABS gives me. And since my printer can do it, I see no reason to print in any other sort of plastic like PLA or PETG. Several years ago, a local hardware store went out of business, and I attended the auction where I picked up a number of storage cabinets, as well as a lot of hardware. And some of these hardware bins I still use on a daily basis. It's really convenient to have these in my shop. I just have to remember to occasionally restock them so I continue to have them on hand. I've been able to stay at home and spend most of my time here tinkering in the workshop, but I have two daughters who have jobs where they're considered essential. One is a nurse and the other works for the US Post Office. In between printing these motor adapters, I've kept my 3D printer busy making surgical mask ear savers for my daughters and their coworkers. So the final step is to get this mounted onto the milling machine. I want to get a dial indicator on there and see what kind of runout we have on this pulley. So it's looking to me like we have just under 1,000th of runout on the pulley. We have more than one high spot per revolution, which is kind of indicating to me that it's in the pulley itself. One thing I find a bit interesting is the spindle pulley, which I haven't touched at all, is measuring 3 thou of runout. Now, 6 years ago, I did fire this thing up and I ran the spindle up to 10K without any vibration at all. So I'm curious to see how this is going to work. And I'm almost to the point where I can fire it up, but I've got a bit more work to do on the electrical panel before that can happen. I got a few more components to hook up, but that's going to have to wait till next time. For now, if you want to see where we last left off with the electrical panel, click that link to the left and I will see you over there.